Good afternoon. You've joined us on Likeable Science here on ThinkTech Hawaii, live streaming from the ThinkTech studios in Pioneer Plaza. I'm your host of Likeable Science, Ethan Allen, and we're exploring how to make science more accessible, more appealing, and broaden that understanding that science is really a vital, dynamic, fascinating part of everyone's life. To help me explore that today, I have Mr. Hawai'i McGivern from Renewable Water Technologies. He's a project engineer with this new sort of startup company. Welcome, Riley.
Hello.
And Riley was born and raised here in Hawaii, went off to Boston University where he got a bachelor's degree in science from Boston U, and then came back here and got his master's in mechanical engineering from UH Manoa. He, with his advisor then, he developed a prototype system for solar powered distillation, and has now sort of moved this into the field a bit for some field testings, or beta runs, I guess you could call them. And that's what this group, Renewable Water Technologies, is involved in. They're fine-tuning things. So welcome, Riley. And maybe you could just start by giving us a little bit of the sort of background on what is this solar distillation process?
Okay, well, usually we talk about solar desalination. What we're doing is a distillation process, but we like to emphasize that we're doing desalination of seawater. So we're producing fresh drinking water from the ocean or any kind of salty sea water source. But because it is a distillation process, we can process gray water or other types of water too and produce pure drinking water.
Excellent. Yeah, well, this is very exciting because in general, distillation particularly is a power-intensive process. You have to put a whole lot of energy in it, and you're doing this all directly from solar, right? Yes. Well,
distillation is basically an evaporation and condensation process.
Mm-hmm.
So it's very similar to nature's rainfall cycle. So actually we don't need to boil the water as with some other technologies, thermal technologies. So this distillation process is it's less energy intensive than a lot of the conventional desalination methods right now.
Yeah, no, that's what makes it so, I think, so exciting to see this and so broadly applicable. I have a project on improving access to drinking water in Palau, the Marshall Islands, and Chuuk and Yap states in Micronesia. And when I saw Renewable Water Technologies solar system here, I got very excited about this because I see broad applicability to the communities that I work with out in the U.S. affiliated Pacific Islands here. Mm-hmm. So this is really, it's one of the nice things about this, as I understand it, this system is completely sort of self-contained, right? You're really off the grid.
Yes, so what we are doing is this solar desalination. So it's powered completely from renewable sources. One of the advantages of our desalination method is that we can use renewable energies or any kind of waste heat source. We just need heat. We don't need high-grade energy like electricity. Or the main power source is low-grade energy like heat or waste heat. So we can run off of just heat from the sun using solar thermal panels, or we can even use industrial waste heat.
Okay, so
and so because it's renewable, it can be off-grid. We don't need to be tied into infrastructure, into electricity. All we really require would be a saltwater source, and if we're doing solar, then we just need somewhere that has abundant solar insolation.
Right, well this is why I got very excited when I saw this, because the places I'm working my project in are all close to the equator and have abundant heat from the sun. And they're all small island states, so they all have, you can't get very far from the water. In some of them, like the Marshall Islands, you can't get more than 100 yards from the water anywhere in the whole country. So yeah. It's quite an applicable system, I think. So how did you get involved in all this work? What motivated you to start it?
Okay, well, maybe I have to backtrack a little bit to my days at Boston University. So, when I was a senior, I'm starting my job search and looking for job opportunities, and I realized that all of the job fairs were offering jobs on the East Coast, but yet I wanted to return home to Hawaii, so I didn't really have a connection between the East Coast and back home. So from there I decided, okay, well maybe I want to look into pursuing further education, getting a master's degree at UH. So I applied to a lot of master's programs at home and along the West Coast. And then what happened was I basically simply said I want to work with renewable technologies, alternative energies, and so this professor at UH, Manoa, Dr. Waylon Koo, he contacted me and said, hey, take a look at my research opportunities, see if any of them interest you. He would like to work with me. So I took a look at his list, and he had this solar desalination project, and it really piqued my interest, and it really hit home. So I said, yeah, I want to get on board. And so from day one, I started working on this project for my master's thesis. And we started by developing a lab scale system. From there, I got my master's thesis done, finished. And I graduated, and I did a job search. But at the same time, my professor, he was looking for sources of funding and was able to team up with another person, John Chalk, who was at the time at the UH Business School. And they were able to form Renewable Water Technologies with some funding that they found. And that allowed us to move the system out from the lab to a field test.
Uh-huh.
And actually start to integrate the technology with solar technology.
Very neat, yeah. So you've got your field site in Kaka'ako, I believe.
Yes.
And you have a system set up there that can produce how much freshwater per day?
So when we first got started, we did a small proof of concept type of system. It was just 6 solar thermal panels, and the system we built it into a garden shed, so it was fairly small. But that system had a capacity for 20 gallons a day, and since then we've developed a new system that's been scaled up 10 times to 200 gallons a day.
Okay.
And a little bit more about our most recent system. It's also containerized into a 20-foot shipping container. So we've placed a lot of emphasis on making this system portable and mobile, deployable, and at the same time increasing its efficiency to produce more water with less energy input.
Yeah, that's a very valuable aspect, is to make it, as you say, deployable, so it can go out. It can be sort of dropped in place anywhere, and more or less hooked up to appropriate hoses, I guess, and just sort of kicks into gear.
Yeah.
Excellent, excellent. Well, that sounds very exciting, and look forward to seeing where it's going to go. So your focus on the renewable energy and the use of solar power or waste heat here seems very appropriate to Hawaii, because Hawaii, of course, we spend huge chunks of money bringing in fuel and to produce electricity and all. So this seems like you've hit a nice, very appropriate use of technology here, taking an abundant resource here, the solar heat, and in some cases waste heat, and using it to produce something we all very much need, which is fresh water. That's great.
Yeah, that was one of the reasons for coming home, because Hawaii really has a lot of sources of alternative energy. We have wind power being developed here, a lot of solar. There's even people looking into wave energy. We have geothermal energy, and so it's really going to be developing. We're going to be developing a lot of new technologies here related to renewables.
Yeah, and there's so much pressure to do it here, because we as you say, there's a number
so isolated.
So there's a number of options, and the bringing in fossil fuels is basically pretty hideously expensive. So,
yep.
Excellent. Maybe we should take a quick look at your system then. We could do that video. If our control room could run that video, we can take a look, and you can maybe tell us as that runs what we're seeing here.
Okay, well, this picture here is our containerized system. You can see that the system is made of these towers. We have two towers. One is for evaporation and one is a condensation tower. I didn't get a chance to explain the technology yet, but we're mimicking nature's rainfall cycle of evaporation and condensation. So what we're doing is we're using the sun's energy, solar power, to heat up the water. So this video here is, we actually got the chance to work with concentrated solar power provided by Sopogy. And here I'm just showing the concentrated solar panels. These are actually clamshells. They open up and they track the sun as the sun moves over the sky through the day. And so they focus all of the sun's energy onto one pipe, which superheats the water. And that is our heat source. So in order to run our desalination system, we mainly need a heat source. We don't need high-grade electricity. We can use, like I said before, waste heat or any kind of thermal energy source. So the sun happens to be a really good solar thermal energy source. So we can provide a lot of heat to our system using just regular flat panels or these concentrated solar panels. And now this video here is showing a test we did using waste heat from a generator. That's a CAT 45 kilowatt diesel generator. And these generators actually produce a tremendous amount of waste heat. No engine can be 100% efficient, so nearly 50% of the energy is actually put into waste heat. So that we have, you can see air ducting connected to the top exhaust, and that exhaust is coming out at really high temperatures, 500 degrees Celsius. And so we're capturing the hot exhaust air into that air ducting system, and we have heat exchangers to exchange that heat to the water in the bottom portion that is being zoomed on in right now. So that's the other, I guess, option for heat. We can actually use waste heat. Down the line, we could look into waste heat from a power plant to collect even more, or geothermal energy. But this again is just showing the system containerized into a 20-foot shipping container.
Excellent. That's a pretty amazing system, and nice to see that flexibility in it. So you can use, I mean, I guess it would require a certain amount of setup to shift from the waste heat to the solar, but the basic components of your system will work either way. That's gives you some nice different kinds of options for different situations.
Yeah, so I didn't get to really talk about yet the niche that we're targeting. So this system is kind of a small scale system. We are kind of developing it with an emphasis on portability and making it deployable, because this is a system that the Navy is really interested in for humanitarian assistance and disaster relief programs. So whenever there's a disaster, they send out units to provide electricity. So almost always they send out a diesel generator. So disaster sites have this diesel generator already there providing electricity, and if we can run our system just off of the waste heat from that generator, then we can be producing basically free water off of what would be wasted heat. And in every disaster situation, water is one of the first things that is needed. And what is normally done now is they're just shipping bottled water out there, and it takes a lot of manpower to load it up. It takes a lot of fuel to fly it out there, and then you unload it, and then you have the waste product from the bottles. Whereas for our system, we could ship it out there or fly it, or however, set it up within a day and start producing fresh water sustainably and basically for free without any infrastructure needed off-grid. So that's the idea behind using the generator, but showing that our system can just be run off of thermal heat and we don't need a major electricity source.
Excellent. This is very exciting. I'm talking with Riley McGivern of Renewable Water Technologies here. We're talking about solar distillation, or solar desalination, I guess. And we're going to take a brief break, and then we'll be back.
Hello, I'm Jay Fidel of ThinkTech. On March 27th at the YWCA downtown, Laniakea, we're having a luncheon program, a luncheon panel program we call the Midterm Legislative Report. We're going to present our 2014 Legislative Midterm Update, featuring Bob Toyofuku of Hawai'i Advocates as our moderator, and a panel of leading state finance officials who will tell you about what's going on in the legislature about money this session. It's really important. Senator David Ige, chair of the Senate Ways and Means Committee, Representative Aaron Ling Johansson, co-vice chair of the House Finance Committee, Representative Sylvia Luke, chair of the House Finance Committee, Calbert Young, State Budget and Finance Director, all the people who are very important, who know about the state fiscal policy, the state finances this session. You know, they say we have a spare $884 million. How much do we really have? The Council of Revenues changed its mind about projections. And how are we going to spend that money or not? What effect will our, current $40 billion of unfunded liabilities have on all of this? And in an election year, what are the real priorities that are going to determine the money bills and the final result of the 2014 legislature as far as you are concerned? We'll cover current fiscal issues, bills of interest of the business community, and we'll look at the provisions, political dynamics, probabilities, price tags of crossover and passage this year. It'll be very interesting to find out what is going to happen here as far as your bills are concerned and as far as state initiatives are concerned. It's an essential program for anybody who wants to know the fiscal state of the state, or if you want to network with the legislators and like-minded attendees who are likewise interested in the subject. Sign up on thinktechhawaii.com. We look forward to seeing you there. Aloha.
And we're back on Likeable Science. I'm your host, Ethan Allen. I'm here with Riley McGivern of Renewable Water Technologies. We're talking about solar distillation and desalinization today. And this is a great technology that Riley and his colleagues have worked out, where with either waste heat for instance, from generators or other industrial processes, or with solar power, they can extract good, fresh drinking water from seawater. So let's dig in, if we might, to this system a little more deeply. And if our control room could pop up the first of the pictures, we can sort of. I can get you to sort of go through the different parts of the system. Okay,
well, just to reiterate, we're doing an evaporation and condensation process. So we like to call this humidification, dehumidification, desalination, or for short, just HDH, desalination. And so again, we're mimicking nature's rainfall cycle. So we have two towers, as you can see in this image. One of the towers on the right is for evaporation. The tower on the left is for condensation. And off to the far right is a solar panel connected to a water tank. So to explain that one quickly, it's very simple. It's very similar. It's actually the same product that a lot of houses have on their rooftops in Hawaii. It's a hot water panel. It's not a PV panel, but it's a solar thermal panel that just collects heat and heats up hot water. And so in order to run our system, we need the evaporation tower to be hot and we need the condensation tower to be cold. So the sun provides the heat to the water for the evaporation tower. And now what we are doing is we're spraying hot seawater into the evaporation tower. And if you think about when you take a hot shower, immediately you have steam generated in your shower room, and that's what's happening in the tower. We're spraying this hot seawater and it immediately creates steam, and at the same time we're blowing air through the tower, so we're mixing the liquid phase and the gaseous phase, and the air becomes humidified. The steam humidifies the air picks up water vapor, and the hotter the air is, the more water vapor it can hold. And so when the air is nearing boiling temperatures, it can hold a very significant amount of water vapor. So from there, the humidified air moves over into the condensation tower, and in that tower, we provide a cold source. Usually we spray cold fresh water into that, and that reduces the temperature of the air, and then that causes the freshwater vapor to condense out of the air, basically precipitate and rain, and that is all just pure freshwater production, and it's collected on the bottom and it goes to a freshwater reservoir. And so that's the basics of it. This schematic is just kind of a simplified version just to explain the HDH process.
Well, excellent, and that's very interesting to see it. You must have a little bit of photovoltaics in there to run your pumps and your control systems, I assume, but
Yes,
but that's relatively minor.
right. So this system, you can see it only involves 2 or 3 water pumps and 1 air blower to circulate the air. And these water pumps are very small compared to other desalination systems. They have really high flow rates, but our flow rates are, more often than not, it's less than 10 gallons a minute. So these are fairly small pumps that require fairly small electricity load. So the majority of our solar panels are solar thermal panels to collect heat, but we do have just a few PV panels to provide electricity to our pumps and air blowers.
Right, that keeps the whole thing, as you say, off grid and sustainable.
Yes.
That's great. Let's go and look at these next few pictures just to get again a sort of a more real sense. Maybe you can tell us what we're seeing there.
Okay, well, this picture is actually the lab scale system that I developed at UH. You can see the 2 towers in the system. I have some water tanks underneath, and this system was powered off of the electricity from the lab. Because it's indoors, we couldn't set up solar panels, but we proved that just by using thermal heat, we could do this process. And it was interesting because the results that we obtained from this lab scale test is it showed that the energy consumption to produce a certain amount of freshwater volume, it was the same efficiency as an electric distiller. So, which makes sense because it takes the same amount of energy to evaporate water, but we are showing that we can do this distillation process through low-grade thermal energy and waste heat instead of having to use an electric distiller and plug it into the wall.
Great. And the next picture?
Okay, and the next picture is the first prototype out at Kaka'ako. This is our first field test with the 6 solar panels, and inside of that garden shed is all of the components. If you go to the next picture, you can kind of see a little bit inside of the garden shed, but very similar to the lab scale system. The towers were about the same size, but the goal of this, I guess this was a proof of concept and a demonstration to show that we can indeed integrate the solar thermal technology with our desalination technology. And the next picture. And so from there we moved on to containerizing our system and scaling it up 10 times. So this system was scaled up 10 times to 200 gallons a day. And this is the containerized system that was actually connected with the concentrated solar panels and also the waste heat generator. And on top of the container you can actually see the PV panels that are providing electricity to the pumps and blower. And the next picture, you can kind of see our operation here. Each container is supposed to have their own desalination system, and actually the third container on the right is just storage for us. So the first 2 are, we have 2 units, 2 desalination systems, each capable of 200 gallons a day, but both of these systems are scalable and modular, so we can actually increase the capacity well beyond 200 gallons a day. The freshwater production is directly related to the energy input, so if you have more solar panels, or if you can supplement it with another heat source like waste heat and solar, then we can produce even more water. And so from here, we're hoping within the next year or 2 to be able to scale it up another 10 times to 2,000 gallons a day.
Excellent, excellent. That's very, very exciting to see this. See how you built this up from a sort of small lab scale system to an initial field test to your next level of where you could really be usable in terms of the amount of water it's producing.
Yeah, and I'd like to emphasize that Renewable Water Technologies is a startup company. I'm the only full-time employee, so I pretty much had to put my blood, sweat, and tears into building all of those systems.
Yeah, no, it's while it's a beautifully simple system in some ways, there certainly are a lot of different parts, and it's a testament to your many talents that you're able to deal with all these different aspects of it.
Thank you.
In addition to what I gather you were saying earlier, there's a whole other layer of it in terms of the permitting and the
Yes.
the sort of paperwork end of things.
Right. So our next step would be to take it out of Kaka'ako and actually put it into a customer's hands, set it up at one of their sites, and really do a real world type of test. So we've really only done demonstrations and data gathering and collecting, but we are talking with a customer on the North Shore to set up a system there and to provide fresh water to their drip irrigation system for agriculture. They want to start growing some vegetables on their property.
That sounds like a great application of it. You can see these systems growing and multiplying, as it were, right? And
Yeah.
greening of coastal areas.
Yeah, and I guess there are the permitting processes that we need to still figure out in order to realize this system in the real world. There's issues of brine disposal. We have to figure out how to return the leftover salt and brine water to the same water source, either return it back to the ocean with mixing functions to reduce the effect on the environment, or another option would be to create a salt pan to evaporate the water and maybe create some Hawaiian sea salt. But there's a lot of other steps involved before we can penetrate the marketplace.
Sure, but in the meantime, it seems like you have some great options in terms of your work with the using the waste heat off the diesel generators. So you could maybe get a little bit of a niche market going, as it were, in terms of being a part of a disaster relief effort, and really demonstrate the ruggedness and value of the systems in that way.
Yeah, for the past few years, that is the direction we've been going, and we've been focusing on that. But we're also realizing now that even on Oahu, not even considering the other islands, even here, there are a number of farmers who are in remote enough locations where they don't have good access to fresh water, or they realize their water resources diminishing and they're looking for sustainable options. So it could be another niche market here for farms, or also resiliency against disasters, even at home.
Yeah, and then even more so, as I was first impressed by your system, thinking about the remote atolls in, for instance, the Marshall Islands, where water is at a real premium because they're totally dependent upon rainwater at this point, and have very little groundwater to work with. And when they have prolonged droughts, as are becoming increasingly common, right now the government chips in water to them, and that's certainly not a sustainable option at all.
No, yeah, not at all.
So it looks like you have several very interesting options, and to make this system sort of find its home, or its homes, as it were.
Yes.
Excellent. So when you do one of these, and you mentioned this earlier, they're pretty quick because they're all sort of containerized, put together. You can take one, drop it in a place, and set it up in how long?
Well, the major installation would be installing the solar panels. So, if we were to do a waste heat off of a generator type of system, we could set it up within a matter of minutes. We just have to take out the waste heat recovery system, just connect it to the generator, and then everything would be pre-built into the container and ready to go. So, matter of our goal is to create a system that would run autonomously. You just have an on-off switch, so as long as you have the heat source plugged in, then you can just switch it on and start making fresh water immediately. But if we were to install solar panels, let's say 30 solar panels or so, a team of maybe 7 or 8, I think they could probably get it done in one day. But we are exploring racking, also floating anchors, so that we can just, we don't have to dig into the ground to install these solar panels. We can just put an anchor that sits on the ground, and we can just install all the panels right there. So we're looking into ways to make the installation quicker and easier, simpler.
Sounds tremendously like you're very forward thinking about it, and this idea too that it really is just you put it in place, connect it up, and then essentially flip a switch and it's ready to go, and requires very minimal, it sounds like, maintenance.
Yes, so I guess comparing our technology to conventional desalination technologies, we can operate under relatively low temperatures, low pressures, or near ambient pressures, and there's very low maintenance. Another advantage of our system compared to conventional technology like reverse osmosis is that our system is not sensitive to salinity. So when I'm talking about reverse osmosis, this is a membrane technology which basically is a series of filters, and it requires an immense amount of pressure to push the water through these membrane filters to take out all the salts. And the more salty the water is, the more energy it's going to require. Whereas our system, using evaporation, it doesn't matter how salty the water is, we can still evaporate at the same rate. It's not going to require more energy. So that's one advantage of our system. And the other is the maintenance. We don't have a lot of moving parts. It's pretty passive. The only moving parts, again, are the water pumps and the air blower. If we have a seawater intake, we're going to need a strainer to keep out any large particulates coming in from the ocean or whatever the source is. We don't want that to go into our system. So the maintenance could be something as simple as every day just opening up the strainer, taking it out, dumping it, putting it back in, closing it up, and it'd be ready to go for the next day. There's no complicated electronics, really no moving parts, just the pumps. So.
Wow, that makes it seemingly, again, to have great applications for remote locales where you don't have the technical expertise. It's hard to get the spare parts, because that's often been the failure of technologies in those locations, has been it's too complex. One part breaks and the whole system is down for a year or two, and there's no one around to fix it. So it sounds like you're doing great. I'm Ethan Allen. You're watching Likeable Science. We're going to take a little break here. My guest today is Riley McGivern, Renewable Water Technologies. We're talking about solar desalination and distillation. We'll be right back.
Hi, I'm Attila Saras, host of Next Big Thing, the ThinkTech show, where we give people a place with great ideas, a chance to share them with the world. Be sure to tune in this Friday from 4 to 4:50 p.m., and I will see you there.
I'm David Day, host of ThinkTech Asia. We're here at 4 o'clock every Thursday on topics involving international security, foreign policy, geopolitics, and international business. I'll see you there.
Aloha, I'm Jay Fidel of ThinkTech. We have some news for you. In addition to our ThinkTech TV show and our Asia in Review show on Olelo 54, as of January 1st, we're adding Community Matters to play also 2 hours a week. Check out thinktechhawaii.com for the specific times of each of these shows. We hope you enjoy all three. Mahalo, I'm Jay Fidel.
Aloha, I'm Maria Kashem of ThinkTech Hawaii, and I want to tell you about our ThinkTech talk shows. If you didn't know it, ThinkTech streams video and audio for all of its shows live on the internet from 2 to 5 p.m. every weekday afternoon, and we replay them all night long on Ustream.tv. Visit thinktechhawaii.com for our live stream and YouTube links. Raise your awareness on ThinkTech. I'm Maria Kashem, and I'll see you there.
And we're back with Likeable Science here at ThinkTech Hawaii. I'm your host, Ethan Allen. With me today in the ThinkTech studios is Riley McGivern of Renewable Water Technologies. We're talking solar desalination and distillation of water, producing fresh water from the heat of the sun. And we've been talking about some of the details of the systems. I want to ask you now, Riley, sort of in developing this, I'm sure you faced some technological, sort of scientific types of challenges. Can you give us a sketch of the big hurdles you had to overcome?
All right. Well, anytime you deal with desalination, you're dealing with salt water, and one of the biggest obstacles is seawater corrosion. There are almost no metals that can withstand seawater corrosion, except for titanium. So I have to deal with some titanium components, and also some plastics are good to resisting seawater corrosion. So one of the biggest obstacles is figuring out what materials to use and looking into material science. And also, when you're dealing with fresh drinking water, you need to make sure all materials that are in contact with the fresh water are approved for drinking water. You don't want any, if you're using plastics, you don't want any contaminants leaching from the plastics into your drinking water. So we have to be mindful of seawater corrosion as well as providing safe, clean drinking water.
A lot of interesting challenges here. It sounds like you must have some good conversations with material scientist type folks and all.
Yeah, I have to consult a lot of, I guess, chemical resistance guides, and also be mindful of the maximum temperatures for these materials. And so that's basically the biggest challenge.
Excellent. Now, I know, as in this kind of project in particular, because you're really moving things out of the lab, you've had other challenges, though, beyond the scientific and purely scientific and technical ones. Certainly funding has had to be a challenge, and then I suspect you might have run into other ones in terms of, 'cause you're sort of introducing a rather innovative technology, and sometimes being on the cutting edge isn't always the most comfortable place to be.
Yeah. I guess in terms of competition, there's not too much competition to what we're doing. We found one company maybe in Germany that is doing something similar, but funding is a big issue. We are doing R&D, research and development. We're a fairly early stage company. We've been around for maybe 3 years, going on 4. So we really are dependent upon grants and having the funding coming in. If we don't have our funding, then we kind of are at a standstill. So we've been lucky enough to have received 4 contracts from the Hawai'i Technology Development Venture, HTDV, and they're getting their funding from the Office of Naval Research, ONR. So we've been lucky to have those grants given to us to develop this technology and continue our research. But we are always looking for more grants and investors to keep our operations going and to keep developing this technology. So I think that's probably been one of the biggest obstacles too, just being able to stay afloat. Sure.
I mean, any sort of science and requires money to do it, and that's for everyone. It's a challenge. Have you faced much sort of opposition to this work from any groups, either on environmental grounds or opposition from power companies because you're sort of doing an end run around the use of power or anything like that? Or?
No, I mean, we've been well received by most everyone we've talked to. I mean, really not much negativity. Everyone's really excited to see this technology, and a lot of people say to me like, oh, I was wondering about this kind of thing, like how come it hasn't been done before, or they just have really positive things to say about it.
That's great. So then what do you see sort of moving ahead? What do you see as your next big hurdles or big challenges you have to overcome?
Well, as an engineer, it's always about increasing efficiency. So, there's because this is a startup company and a really new technology, there's so many things that I want to be focusing on and working on and improving, but it comes to a point where I need to prioritize and figure out, okay, what is it that I'm going to work on right now? And so at this point, it's basically doing more testing, trying out new configurations. There's so many variables, temperatures, flow rates, energy inputs. And so it's really about developing the technology and optimizing it, getting it more efficient, producing more fresh water with less energy. And then the other emphasis is getting it ready to be moved somewhere else. So packaging of the system. And then I guess the next step would be to set it up for a customer somewhere, and then we have to tackle the issue of brine disposal again. So figuring out what permits we're going to need, how to dispose of the brine water, just creating, I guess, new schematics in order to make this thing work in the real world, simply, easily, effectively.
Cool.
Yeah, so.
That sounds great. We're going to take another break here. I'm Ethan Allen. You're with us on Likeable Science. I'm here with Riley McGivern from Renewable Water Technologies, and we'll be right back.
I'm Jay Fidel. That's Sharon Moriwaki of the Hawaii Energy Policy Forum. And every Wednesday we have Hawaii, the State of Clean Energy. We've been doing it for some time now, and we have some fantastic guests on there, unbelievable guests who give us insight into what is going on in a very complex, sometimes very confusing, sometimes very disappointing area of progress in the state. So we love doing this. We love meeting them. We love talking to them. We love having their ideas out on the table. So maybe, just maybe, we can all make some sense of what's going on. Sharon, what do you think?
I think that's absolutely correct. We enjoy ourselves meeting with all these people and hearing about the energy and the state of clean energy, and hopefully we advance clean energy for the state. So it's terrific. Join us.
Okay, it's every Wednesday. Okay, Wednesday is Energy Day. Every
Energy
Wednesday, 4 to 5 p.m. Hawaii, the State of Clean Energy, here on ThinkTech Hawaii.
Energy
we'll see you
Wednesday.
there. I'm Jake.
And you're back on Likeable Science. I'm your host, Ethan Allen. We're broadcasting from the ThinkTech studios in Pioneer Plaza. With me in the studio today is Ryan McGivern from Renewable Water Technologies. We're talking about solar distillation and desalination and the wonderful new system that RWT has for this. I want to sort of walk with you to the future a little bit here. Where do you see this all going? I mean, you've been prototyping a system or field testing a system, and you're going to try to get it out to a customer. 5 years from now, what do you see? Where do you see this? What do you hope is going to happen?
Well, first of all, we would like to scale up our system even more. Right now our system capacity is 200 gallons a day, and a lot of people and customers are looking for in the thousands of gallons per day. So hopefully we can scale it up another 10 times to 2,000 gallons a day or more. We would like to set up more systems island-wide as well as overseas. Really, I guess if you look at the trend of freshwater, you can tell just freshwater scarcity is increasing worldwide. And as well as in Hawaii, we have a large freshwater reservoir on Oahu, which is why we can sustain such a large population here. But a lot of the other islands, they don't have as much fresh water, and they can't be populated as much because of it. And I've heard that the consumption rate for fresh water, even on Oahu, is larger than the replenishing rate, which means our freshwater reservoirs are diminishing year by year. So in the future, I can't necessarily say when, but it seems almost certain that we're going to run out of fresh water in the islands too one day, and we will need to turn to rainwater catchment or desalination, or more likely both, combination of both.
Right, probably several technologies. And yes, from what I understand, there are historic records of multiple stream flows in places that now there is no water flowing. So suggesting the water table is dropping. We are, as you say, sort of sucking water out faster than it's filling back up. And so this kind of technology that you're developing would seem to be a very sensible route to go.
Yeah.
And it seems like we have several markets for this. It can be used in disaster relief. It can be used to produce drinking water. You were talking about a customer wanting, or customers wanting to use it for agricultural purposes. So it seems like you might have a lot of places you could work this and hopefully find some marketing.
Yes.
Indeed, it's you can sort of envision this along, say, along the edge of the Mediterranean Sea and at the edge of the Sahara Desert, sucking water out of the sea, greening coastline there, as it were. And you had said you were talking to people in other parts of the world.
Yes, mostly Pacific Island nations. I mean, the Middle East and the Persian Gulf, they're already highly dependent on desalination, but they have the fossil fuels to be able to power those large plants. So we would probably stick to more remote island locations along the Pacific. We're targeting places in the tropics, somewhere where it has abundant solar energy, as well as, a large saltwater source, the ocean or whatever it be.
Well, yeah, no, that absolutely fits, and it's again, this brings me back to my initial fascination with the system when I saw it. It was because of the work I'm doing in the islands on drinking water availability. And from what I know of the sort of looming crises for some of these places, it seems like you have a system that is remarkably well aligned to meet needs that are going to be doing nothing but growing in over the next upcoming years. So,
I have a friend who just recently visited Bermuda, and I guess it's law that every square inch of all their rooftops have to have rainwater collection. And so they survive solely off of rain catchment, as I assume a lot of other places do as well. And with climate change and changing rainfall patterns, a lot of places could get stuck without any fresh water. So it's something that we're really thinking ahead on, hoping that we could get our systems out to a lot of places, a lot of small island nations, and that's the whole idea.
so what's your capacity? If somebody told you tomorrow, hey, we need 10 of these 200-gallon-a-day systems, could you put those together in some reasonable time frame, do you think? Or do you feel like there's more, do you still need to do more field testing groundwork before you'd be ready to move ahead?
We're still a really early stage company, so I myself couldn't build that many systems in a short period of time. But hopefully in the future down the line, we can expand our company and grow and have more workers and be able to develop a commercialized product that's robust and portable and efficient. And I guess that's kind of the long-term goal.
And so, do you have a sort of a vision of your success? How will you know when you've succeeded?
I guess that's kind of relative. To me personally, I'll feel successful if I affect change in a lot of people's lives, if I can help out people. And it's not until you put yourself in a situation where you have there's freshwater scarcity that you realize the importance of every drop of water. So I think if I'm able to provide just even a few gallons to each person, I think when you're in the situation with no water, they'll be really happy, and they'll make a huge difference.
It does. It makes a tremendous difference. I know from my travels in the region that water is indeed scarce, that many people do not have what we take for granted, the luxury of just turning on a tap and having water readily available. And systems like what you're developing have just such awesome potential to really alleviate a steadily growing need in these places. So that's I think you guys are, in that way you're already well on the way to success, I guess. And the ability of the system to be used in conjunction with disaster relief efforts, as you were talking about earlier, with the hooking up to use the waste heat from an electrical generator or diesel generator to, again, it seems like that would be hand in hand with making this a broadly usable kind of system with a lot of potential to use it. anyhow, this is basically our time is up here. I want to say thank you very much, Riley. It was a pleasure talking with you. Wonderful to learn about this sort of tremendous new technology, and how exciting for you to be part of such a cutting-edge effort.
Yes, thanks for having me.
Well, thank you very much for being here. Again, I'm your host, Ethan Allen, for Likeable Science. With me today in the studio has been Riley McGivern of Renewable Water Technologies. Stay tuned to this guy. I think the system is going to really go somewhere.
Thank you.
Aloha, Riley.
Aloha.